Let's take a look at these two expressions. Please notice that voltage is represented by cosine. Anytime you have problem like this, where you're supposed to find out which wave is leading, which one is lagging, we prefer to have all equations being the sine equation. So we're going to convert this cosine to sine by adding 90 degrees to the phase shift angle. So I'm going to rewrite this as V equals 3 sine omega t plus 10 degrees plus 90 degrees millivolts. One more time, if you want to convert cosine to sine, you're supposed to add 90 degrees to the phase shift angle. Your equation is going to look like this: V equals 3 sine omega t plus 100 degrees, and everything is millivolts. Next, we can draw the graph. My y-axis is going to represent voltage in millivolts, because I have millivolts, and current and in milliamps. Why? Because I have power of 10, 10 to negative 3. My x-axis is calibrated in degrees. Why? Because my phase shift angles are expressed in degrees. That's why I'm going to find the points. 180 degrees, twice of it is 360 degrees. Also, I have to find 90 degrees and 270 degrees. Let's take a look at the first equation. My peak value is 2.5 milliamps and my voltage is 3 milli. That's why I'm going to have 1, 2, 3 and 1, 2, 3. My current is 2.5. So I'm going to have 2.5 over here. 2.5. I'm going to draw the dash line. And 2.5 is over here, and this is 2.5 negative. My phase shift angle is minus 45. It means that my waveform is going to lag the reference by 45 degrees. Lag means I'm going to be behind the reference point 45 degrees. 45 degrees is half of 90. So this is my 45 degrees. So this point has to be also moved to the right by 45. 90 plus 45 gives me 135. 180 also has to be moved by 45. This is going to be equal 225. 270 plus 45 is going to give me 315. 360 has to be moved also, and this is going to be equal 405 degrees. Next, you're supposed to realize that we have positive value of current. That's why I'm going to start from the positive half a cycle, and I'm going to have positive peak at angle 135 degrees. I'm going to have negative going zero crossing at 225, and I'm going to have negative peak at 315 degrees and positive going zero crossing at 405 degrees. And my wave is going to look like this. This is the very first waveform for my problem. Next, I have to find the second one. Second waveform is ahead of the reference 100 degrees. That's why I'm going to have 100 degrees. So if this is 90, this is going to be approximately 100. So I'm supposed to write minus 100 degrees ahead of the reference point. And simply you have to move all these points like 90, 180, 270 and 360 100 degrees to the left. Simply 90 minus 100 is going to give me negative 10 degrees. 180 minus 100 is going to give me 80 degrees. 270 minus 100 is going to give me 170. 360 minus 100 is going to give me 260. 260 degrees. Next, my peak value is 3. Going to draw the dash line and dash line over here. Next, I'm supposed to realize that at this point I'm going to have at negative 10 degrees, I'm going to have my peak because this is positive voltage. I'm going to start from the positive half a cycle. At 80 degrees, I'm going to have negative going zero crossing. At 170 I'm going to have negative peak, and at 260 I'm going to have positive going zero crossing. Next I'm supposed to connect all these points together. This is 3 millivolts and this is negative 3 millivolts. Keep in mind that the blue color represents the voltage and the green represents the current. Please notice that your voltage is leading your current by 145 degrees. That's why you're supposed to write that voltage leads current by 145 degrees. Or I'm supposed to say current lags voltage by 145 degrees. And this is the final answer to my problem.